This is R.D. Sharma Solutions, Class 11, Chapter 14, Quadratic Equation, Exercises 14.2. So there are certain questions we have to do by factorization. There are certain questions we have to use the quadratics, that is the Sridharacharya formula. So x square plus 10i minus 21 is what we are going to do here is, we are going to put I square here, so this is going to become plus. And this 10ix I am going to write 7ix plus 3ix. Now you can take a x common from here, you get x plus 7i. You can take a 3i common from here, you get x plus 7i. So now x plus 7i you can take common, you get x plus 3i inside. Now you put this as 0, x will be minus 3i. You put this as 0, x it will be equal to minus 7i. Here x square plus 1 minus 2ix minus 2i. Now open it. X square minus x minus 2ix minus 2i. Take a x common from here, you get x plus 1. Take a minus 2i from here, you get x plus 1. Now take the x plus 1 common from both. So you get x minus 2i and x plus 1 equal to 0. Put this as 0, x will be 2i. Put this as equal to 0, x will be equal to minus 1. X square minus 2 root 3x plus 3i into x. So just open it. It will be x square minus 2 root 3x minus 3ix plus 6 root 3i equal to 0. So now here take x common, you get x minus 2 root 3 inside. From here you take minus 3i common, you get x minus 2 root 3. Now take x minus 2 root 3 common. So what do you get? X minus 2 root 3 and x minus 3i. Put this as 0, you get x equal to 3i. Put you get x equal to x minus 2 root 3 equal to 0, you get x equal to 2 root 3. Here 6x square plus 17ix. Now put I square here, multiply it with I square and make it as plus. Now here the 17ix can be written as 9ix minus 8ix. Now this becomes, take 3x common, you get 2x minus 3i. From here you take 4i common, 2x minus 3i. Now this 2x minus 3i you can take common, you get 3x minus 4i, 2x minus 3i. Now put this as 0, x will be equal to 4 by 3i. Put this as 0, you get 3 by 2i. Here just open it. X square minus 3 root 2x minus 2ix plus root 2i equal to 0. Now from here take x common, you get x minus 3 root 2. From here you take minus 2i common, you get x minus 3 root 2. Now take x minus 3 root 2 common from these, you get x minus 2i inside. So x minus 2i and x minus 3 root 2. Now put this as 0, x minus 2i is 0, you get x equal to 2i. Put x minus 3 root 2 as 0, you get x equal to 3 root 2. Now there are certain questions which need special permutation and combination of the term, and first you can solve, because this is a second question, so you can solve this question in the book. It is given that you solve it using the quadratics or Sridharacharya formula. So I'm going to show it using factorization, but I will tell you that because this are to be solved by Sridharacharya formula, how to solve it I'll tell you, and you can solve it by the quadratics or the Sridharacharya formula, and you can solve it by the factorization also. So let me take you to a question, how to solve this second question, because all the questions have to be solved by this. And once I tell you, you can solve it either by this method or either by the factorization method, whichever is suitable for you, because sometimes it is very difficult to factorize it. For example, this equation 2x square plus root 15ix minus I. Now this is very difficult to factorize it. So the best thing is to use this Sridharacharya formula or the quadratics. For this, what we are going to do, compare it with ax square plus bx plus c. So a is 2, b is root 15i and c is minus I. Now we have two roots, alpha and beta. Alpha is minus b plus under root b square minus 4ac by 2a, and beta is minus of this. Now put all the values, what do you get? These values you get. Now this inside you have to put as a plus ib. When you put this as a plus ib, square both the sides. When you square it, this root goes, it will be minus 15 plus 8i. Now here a plus bi whole square. This is going to be a square plus bi whole square and plus 2 into a into bi. So what do you get? A square. Now bi square, I square is there, so minus it will be a square minus b square plus 2abi. Now compare or equate the real and imaginary part. So real part is a square minus b square is minus 15 and imaginary is 2ab, that is going to be 8. Now we have a formula, a square plus b square whole square is equal to a square minus b square whole square plus 4a square b square. This is the formula we have already talked about. A square minus b square, put it here, 2ab put it here. Now you get a square plus b square. So now you have a square plus b square, which has come to 17. You already have a square minus b square. Okay, so just add it. 2a square is going to be 2. A will be equal to plus minus 1. 2 by 2 is 1 and this is going to be under root 1. So a is going to be plus minus 1. Similarly, if you put a here, what are you going to get? Let me put a here. So it will be 1 square plus b square is 17. B square is 17 minus 1, that is 16. B will be equal to plus minus under root 16 is 4. B is plus minus 4. So in the first view, we look and we see that there are going to be 4 solutions for these alpha and beta. But this is not the case. Why? Because you see here 2ab is 8. That means a and b, either they are both negative, either they are both positive. So what we are going to take, a as 1, then we have to take b as 4. If we take a as minus 1, we take b as minus 4. That is what is explained here. Now because we have already showed that this one is, or assume it to be a plus bi, put this value here. It can be 1 plus 4i, it can be minus 1 minus 4i. So now alpha will be equal to, we already have this one, now we have to replace this term. So we have replaced this term with this, and now we replace this term here, alpha beta. Means first time this one, first time this 1 plus 4i here, and then this term here. Now here, next time we put minus 1 minus 4i. First time we take this and find alpha and beta. Second time we take this and find alpha and beta. We just have to replace this by first this one and here by this one. So now this you understood. This is how we are going to take care of all the questions which are coming under second part. But the thing is that if you are not comfortable with factorization, then you do this method. So let me take you back where we shifted to this point. So this is x square minus 5 minus ix plus 18 plus I. So you can do it by the method I just told you, or if you want to do it by factorization. So let me tell you how it is done. It is somewhat tricky. X square minus 5x minus ix plus 18 plus I it is. So now I am writing this minus 5x as x square minus 3x minus 2x, right? Minus ix I am writing as plus ix minus 2ix. So these two will make minus 5x, these two will make minus ix plus 18 plus I. Now I am taking from here first these let me just check. Okay, x square minus, this is okay, but I am now writing this as 4ix. So let me make it as 4ix minus 4ix, so this will be 3ix. Right, 3ix minus 4ix will be minus ix. Now this one, and this one I am taking together. This one I am taking together, minus 2x minus 3ix, and this is already there. Now from here, x square, take this. From here, you can write it as, say you take x common. It will come as 3 minus 4i. From here you take minus x common, you get 2 plus 3i. And you have plus 18 plus I. What do you get? This one, take x common. You get x minus 3 minus 4i. From here you take 2 plus 3i common. So you have what? You have x and minus. What will be the term here? What would you multiply with 2 plus 3i to get this term? What you can do here is, you can divide it 2 plus 3i, you can get the term. But let me tell you, this term will be 3 minus 4i. If you multiply these two terms, you will get 18 plus I. That is why I did all these computations. So this will be simply 3 minus 4i. If you multiply these two, 18 plus I will come. Now you can take it like this, x minus 3 minus 4i common. So what do you get? X minus 2 plus 3i here. Now put this as 0, you get 2 plus 3i. Put this as 0, you get 3 minus 4i. Here you have this term, 2 plus I x square minus 5 minus ix plus 2, 1 minus I. So now this 2 plus I x square. I'm writing this as minus 5x plus ix. Minus 5x, I am writing it as minus 2x minus 3x, right? And this is minus ix, so let it be minus ix plus 2 into 1 minus I. Now from here, these I'm making it as 2 plus I x square minus 2x. From here I'm taking this as x common, so 3 minus I into x, and this will remain as 2 1 minus I. Now from here take x common. What do you get? 2 plus I into x minus 2. From these two take 1 minus I common. If you take 1 minus I common, what you have to put it here? You can divide this 3 minus I by 1 minus I, but I can tell you that when you divide these two, you are going to get 2 plus I. If you multiply 2 plus I with 1 minus I, you will get this one. So this is going to be minus 2. Now take these two common, that is x 2 plus I x minus 2. This will remain inside x minus 1 minus I. Now put this as 0, you get x equal to 1 minus I. Now put this as 0, so 2, this, if you put this as 0, 2 plus I into x minus 2 equal to 0. X will be equal to 2 by 2 plus I. Now just multiply 2 minus I numerator denominator to get the denominator done. That means try to rationalize it. You get 4 by 5 minus 2 by 5i. So one is this one is this one. Now x square minus 2 plus I into x minus 1 minus 7i. As I told you, you can always do it if you have any problem, you are not able to factorize it. You can always go with the quadratic method. So x square minus 2 plus I into x minus 1 minus 7i. For that, what you are going to do? X square minus 2x minus ix minus 1 minus 7i. Now I am writing this x square, this as minus 2x, and I'm taking these two here. So x square minus, take x common, you get 2 plus I and minus 1 minus 7i, right? Okay, when you get this one, I'm just changing this so that I can have some term. So I'm writing this as x square minus 3x. If I write minus 3x, I have to write a plus x here because I want this one. Then we have plus ix. If I'm writing pi plus ix, in order to get this, I have to write minus 2ix, right? Minus 1 minus 7i. Now this term and this term 3x and ix, I'm combining together. So x square minus 3 minus ix. This term I am taking x common. You get 1 minus 2i minus 1 minus 7i. From here I am taking x common. X minus 3 minus I. From here you are taking 1 minus 2i common. When you take common, what do you get here? You can just try it, 1 minus 7i divided by 1 minus 2i. You will get this term, 3 minus I. So you can write it as minus 3 minus I. Now put this as 0, it means x minus 3i, x minus 3 minus I is one factor, and x plus 1 minus 2i is another factor. Put this as 0, x becomes minus 1 plus 2i, then put this as 0, you get 3 minus I. Now you have x square minus 4x minus 4i. So ix is there, I am adding an I square here, so I have to make it as a plus 4xi square. This is minus 4, so I am making it as plus, and I am adding an I square here. So this will be ix, this will be 4i square x, and this will be 4i cube. Now divide both sides by I. All one I will be eliminated. X square plus 4ix plus 4i square equal to 0. Now write this, 4ix has 2ix plus 2ix. Now take x common from here, you get x plus 2i. You take 2i common from here, you get x plus 2i. So this is simply x plus 2i whole square. So you get x equal to minus 2i, x equal to minus 2i here. Here you have to do nothing, just multiply it by I square, make it as plus. So what do you get? 4ix you have to write it as 2ix and 2ix. So this becomes, take x common, x plus 2i. Here also you take 2i, so you get x plus 2i. This is x plus 2i whole square again. X is equal to minus 2i. When you put it at 0, x will be equal to minus 2i. This we have already done, so I'll just skip it. Now here, x square minus x plus 1 plus I. Here, x square, I'm writing it as this minus x. And now I am adding an ix term, and when I have ix term, I have to subtract ix term, right? And then plus this 1 plus I. 1 plus I is here. If I write I into 1 minus I, what do I get? See, I goes inside I, minus I square. I square is minus 1, so this becomes plus 1. So I plus 1 for I, this I plus 1. For I plus 1, I can write it as I into 1 minus I. Okay. Now I am combining this term. I am combining x square minus ix. X square minus ix. This goes together, minus x plus ix. Then we have I, 1 minus I. So here you take x common, x common, so x minus I. Here you take minus x common, you get 1 minus I. You have I minus 1, so make it as a negative. It will be I minus 1 minus I. If you take a negative here, it will be, this will change. So I minus 1 will change as 1 minus I. So now here you can take 1 minus I common from here, x minus I. You can take a 1 minus I common from here. You get x inside minus I. Now x minus I you can take common, x minus I. You get x minus 1 minus I. Now if you put this x equal to 0, x will be I. If you put this equal to 0, x will be equal to 1 minus I. So this is the solution. Now you have this ix square minus x plus 12i. So you have to do this like same, this is a is I, b is minus 1, c is 12. Just put it here, you'll get this term. Now because this is what we have already discussed, so I'll just skip it. The only thing which you have to see here is when you get 4 by I, don't put it like 4 by I and this minus 3 by I like this. Multiply the numerator and denominator by I. What do you get? 4i by, this is I square. What do you get here? Minus 3i by I square. I square is minus 1, so minus 4. I square is minus 1, this gets cancelled. So minus 4i and 3i is the solution. Otherwise, you just have to use this Sridharacharya formula. Similarly, here you have x square minus 3 root 2 minus 2yx minus root 2i. A is 1, b is 3 root 2 minus 2i, and c is root 2. This is minus b plus minus under root b square minus 4ac. So what this you get? Just separate them. This is the final solution. X square minus root 2 plus I into x plus root 2i. So just open it. X square minus root 2x minus ix plus root 2i. So now take x common from here, you get x minus root 2. Now you take I common from here, you get x minus root 2. Now take x minus root 2 common, you get x minus I and x minus root 2. Put this as 0, you get x equal to I. Put this as equal to 0, you get x equal to root 2. Now same thing we have already done and we are going to repeat it because all the questions you can do by this method also. Now compare it with ax square plus bx plus c. A is 2, b is minus 3 plus 7i and c is 9i minus 3. So just put it here, x equal to minus b plus minus under root b square minus 4ac by 2a. So when you resolve it, you get here this root term. All these things you can do. Now this is under root minus 16 minus 30i. Now put this as ax plus iy, or you can also put it as a plus ib, whatever is suitable for you. Now square both sides. When you square it, you get minus 16 minus 30i, this root goes and this is square. So when you have this square, x square plus I square y square, it will be minus. So x square minus y square plus 2ixy. Now compare or equate the real and imaginary term. X square minus y square will be minus 16 and this 2xy will be equal to minus 30. Now we have a formula, this x square plus y square whole square is x square minus y square whole square plus 4x square y square. Now in this place put this one, in this place put this one. You get x square plus y square equal to 34. Now we have already seen how to solve this. solve this one and this one. You get x equal to plus minus 3, y equal to plus minus 5. Now if you see here, 2xy is equal to minus 30. Since this is minus, x will be negative, so y will be positive. When x will be positive, y will be negative. So you can only take the combination like x is minus 3, then y is 5. X is 3 is y equal to minus 5. So x plus iy in this case becomes 3 minus 5y. In this case, x plus iy becomes minus 3 plus 5y. So put this term, you get under root 14. This actually you just get this at 3 plus minus 3 plus 4 5i, because this what is under root 14 minus 8 root 2. This is actually under root 14 minus 8 root 2 I only, because 16 is 4 square and 30 you can take this 8 4s are 32, so 4 can come out and this is the term. So now this is equivalent to this one, so we have x as this term plus minus this term now one time, another time this term, so you get x equal to these two terms here. So this is all about this exercise. Thank you so much. Take care of yourself.